Hey, I feel like doing some more binomial expansion today, and well, today's going to be a lot easier than yesterday, I promise you. Today, our focus is going to be on finding a specific term. Rather than the entire expansion itself, they're going to ask me to identify just one term within that entire polynomial. So as long as we know which term to go after, our work is going to be much easier and quicker than it was yesterday. Now, I want to introduce you to something here. It's very blurry on the screen right now, and I'm sure you cannot read it, and that's okay. But we haven't talked about this yet because it hasn't been an issue. But today's the first time where it's going to be very helpful. And on our Regents exam, we have what's called a reference sheet. Okay, like I said, we haven't given you one because we haven't covered any of the topics that are on here yet. Now, what we've got here, all of this right in here has to do with trigonometry. Okay, so obviously we haven't done any of that yet. We'll start that as soon as we start the third quarter. That's what we're going to dive headfirst into there. Then we have a little section here on sequences in series, and we're going to be doing that very shortly. Down here we have what's called the normal curve, and that goes along with our statistics chapter. Again, a chapter that we'll see within the next couple of weeks. And then right here is the binomial theorem. So that long theorem that we put in our notebook yesterday, it's not something we have to memorize. It's going to be something that's on our reference sheet. But I think, historically speaking, I haven't seen hardly any students in the past even look at the reference sheet for the binomial theorem. It's something that just kind of, by the time we practice it enough, it just comes to mind, like the quadratic formula. It's not something that you really have to look up. You just kind of know it. So there it is. It'll be right on the reference sheet when we give you a copy. Here's just another look at it. I zoomed in on that reference sheet we just had on the previous slide, and so here it is. It's going to look like this on your reference sheet. You'll notice they used all the same notation here that we used in our notebook yesterday. Now, what we have here is kind of a condensed version of that, but we're not going to make a big deal out of this. They're using the sigma symbol that we'll talk about in our statistics chapter, so maybe this will make more sense in a few weeks from now. But as far as today goes, we're going to still focus on this top version that we put in our notebook yesterday. Okay, here's our first example. They gave us the binomial 3x minus 4, so there's your binomial, and they're asking us to raise it all the way up to the 12th power, and you can just imagine what a bear that would be if we had to do this one yesterday. If they wanted us to expand the entire thing out, there'd be a grand total of 13 terms. It would just be huge. It would take us forever to do. But again, doable, but it would take a while. Today, they're going to ask us specifically for only to find the 5th term. Okay, they don't need all 13 terms today. They're only going to ask us for something like the 5th term. Okay, now here's how I set it up. I tell myself, well, I know if I did the whole thing, there would be 13 terms. So I kind of start to set the stage. First term plus the 2nd term plus the 3rd term plus the 4th term plus the 5th term. And then I'm going to put a little ... at the end of that just to show that it does continue on. But I'm not really concerned with any term beyond the 5th term. Now, what goes in there? As far as my setup, I know that the first term should be 5C. Oh, I'm sorry. Nope, scratch that. Should be 12C0. And we talked yesterday about all the patterns that lie within the binomial theorem. And then the second term would be 12C1, 12C2, 12C3, and then our term would be 12C4. All right. Let's see, I'm going to try to make my pen a little skinnier. Okay, now, then we go back here. We know that our A right here is the 3x. So it would start off with 3x to the 12th, and then that power would then decrease term by term. So on the second term here, it would be 3x to the 11th, and then over here it would be 3x to the, what would that be, 10th, and then 3x to the 9th, and then our term is going to be 3x to the 8th. So we got our 3x to the 8th power, and then we're going to go ahead and finish up our b term right here. Remember, we went plus and we made the 4 a negative. So right there's my b term. So we've got -4 to the 0. We've got -4 to the first, -4 squared, -4 cubed. And then right over here, we've got -4 to the 4th power. Now here's the good news. Hopefully you said to yourself that because this binomial had a minus sign in the beginning, this is going to be an alternating polynomial where each term alternates signs. And so we've got a positive term and then a negative and then a positive and then a negative and then a positive. So the good news is our term is going to be positive, which just makes our calculations a lot easier. The other way that you would have known it's positive is because this exponent right here is an even number. Anytime this is an even number, that you're going to end up with a positive term as well. Now for the number crunching, and this was my calculator got to work out here. I plugged in the 12C4, and my calculator spit out 495. Now we're going to multiply that. I plugged in 3 to the 8th, and my calculator spit out 6,561, and then of course x to the 8th. That part wasn't on my calculator. And then I typed in 4 to the 4th, or more specifically negative 4 to the 4th, and with the parentheses around it. But either way, it turned out to be 256 positive. And then I asked the calculator to multiply those three coefficients together. I got 831,409,920 x to the 8th for my final answer. So that whole big booger right there is what we would consider the fifth term only. Okay, example number 2 is going to be extremely similar but slightly different, and I want you to really focus on the slight difference between our first two problems. They gave us the same binomial and they still raised it to the 12th power. They might try to sneak in and ask you, and you got to pay attention to the wording of the question, they might ask you for the coefficient only of that fifth term. Okay, so they might ask what's the coefficient of the fifth term, and this is slightly different because they don't want the entire fifth term. All they want is the coefficient aspect of it. So if you recall the setup we had on that last one, we drew the first 5 terms. Then we said ours is going to be 12C4, and then we had 3x to the 8th power, and we had negative 4 to the 4th power. Basically, I'm going to do everything I did in the last one, except I'm going to disregard any variables that I might have. So whenever you see the word coefficient, just tell yourself, make a note here in your notebook, we're going to disregard any variables that we might have in this setup here. All right, we're basically going to ignore this x that was right there. So again, the 12C4 turned out to be a big 495. Then we're going to multiply that by 3 to the 8th, which turned out to be 6,561. Disregard the x to the 8th, and then negative 4 to the 4th was again 256. And we multiplied those all together, and we got that big, humongous 831,409,920. Disregard the x to the 8th, and now that would be my answer. So, the trick is if they ask you for the coefficient, but you put x to the 8th in your answer, they're going to mark it wrong, okay? So we just got to be really careful and answer exactly what they're asking for. Now, as we progress through today's lesson, I'm going to try to trick you by adding in some extra some more variables, exponents, some minus signs, all that jazz. We're going to try to really keep you on your toes and see if we can stay in tip-top shape here. But in this particular question, we're going to ask you for the fourth term only. I'm asking for the entire fourth term, so we are going to include the variables along with the coefficients. You'll notice that our a term is 2x, our b term is a negative y squared, and we're raising it to the 7th power. If they wanted the entire binomial, there'd be 8 terms, but yeah, that was yesterday where we did all that work. But anyway, first term plus the second term plus the third term plus the fourth term. So that's the one we want. We'll put a little ... just to signify that it does continue to go on. And as far as, if we saw this question on a spiral, putting, something little like that little ... at the end is a big deal to me, okay? That's something that I really find important. Now, think about how you would start this one, and I wish I'd have left myself a little more room for this first term right here. But we would have started off by saying 7C0, and then we could follow the pattern 7C1, 7C2, and then we want 7C3. Okay, back to the first term. We would have said 2x to the 7th power, and then follow the pattern 2x to the 6th, 2x to the 5th, and then we want 2x to the 4th. Last but not least, we would have said negative y squared raised to the 0, and then those exponents are going to increase. So right here would be to the first power, to the second power, and then ours, the term we want, is going to be raised to the third power. Oh boy, now the cleanup comes in here. Let's see if we can handle this. Again, all on the calculator here, the 7c3 turned out to be a 35, pretty manageable number. Multiplied by, let's see, 2 to the 4th, you could probably do in your head, that's 16, and your x to the 4th. Oh, okay. Now, we have a power raised to a power. And again, I think this is worthy of an extra note in your notebook, okay? When we have a power raised to another power, just remind yourself that we're going to multiply those exponents together, all right? And so that's going to turn out to be a negative y to the 6th. You're asking yourself, why is it negative? Well, when you're raising it to an odd power, we're going to end up with a negative answer, okay? Let's see, multiply these three rascals together. That's 35 times 16. I got negative 560 x to the 4th, y to the 6th. And that, ladies and gentlemen, is my final answer for this particular question, because they asked for the whole term. If they would have slightly changed the wording and asked for the coefficient only, then I would have simply said negative 560 and disregarded the x to the 4th and y to the 6th. All right. Now, just like the previous couple of examples, you'll notice, again, we've got the minus sign here in the middle. That tells us right away that we're going to have a polynomial with alternating signs. And I just want you to be especially careful on all of these to make sure we end up with the correct positive or negative sign on our term when we're all done. But anyway, here they want the very last term. Okay, so instead of specifying a certain number, they just said last term. And we're smart enough to know that if we're raising something to the 4th power, we're going to end up with a grand total of 5 terms by the time we got done expanding this entire polynomial. So that's essentially what they're asking for, is the 5th term. So I'm going to go ahead and set the stage. Here's the first term, second term, third term, 4th term, and then our magical 5th term that we're seeking. All right. We'll go ahead and set the stage. We've got 4C0, follow the pattern, 4C1, 4C2, 4C3, and then get your 4C4. We need the first term raised to the 4th power, and then those are going to decrease, so 3rd power, 2nd power, 1st power, and then the 0 power. You're probably wondering to yourself, do I really have to write that term? And my answer is no. If you want to skip that part and disregard a to the 0, I'm fine with that. Now, our b term in this particular example is going to be negative 2 to the, times b. We're going to start off raising it to the 0 and then increase the power. So we've got 1st power, 2nd power, 3rd power, and then finish with the 4th power. Now, could you tell me, when we're all done, is my answer going to be positive or negative? Well, let's do a quick check here. There's 2 ways to know. I could say, well, positive, negative, positive, negative, positive. Aha, I know this is going to be positive when I'm done. Or you could have just said to yourself, because that exponent's even, I know for sure it's going to be positive as well. All right, as far as the calculator work goes, 4C4 turned out to be a 1. A to the 0 turned out to be a 1. And then last but not least, 2 to the 4th turned out to be 16b to the 4th. And by the time I get done multiplying them, I simply have 16b to the 4th. There's my final answer. That's the last of the 5 terms in that polynomial. Our very last example tonight has probably the ugliest combination of exponents and coefficients, etc., etc. And they're strictly asking for the middle term on this polynomial. Again, we're going to have to think on our feet a little bit. We know there's a grand total of 5 terms when it's all said and done. So out of those 5 terms, which one would be the middle? Well, yes, the 3rd term is the one we want. That would be the middle of the 5 total terms. Whoops, spelled that wrong. All right, so we need to go get the 3rd term. That's what they're essentially asking for. 1st term, 2nd term, 3rd term, plus dot, dot, dot. Now, my 1st term is going to start off 4C0 and then 4C1, and I want 4C2. Then, ooh, man, look at this. 5x to the 5th raised to the 4th. And then, let's see, then it would be raised to the 3rd right there. And then the one we want is going to be raised to the 2nd power. And then going back here, this would be negative 3y squared raised to the 0. This would be to the 1st. And then ours would be to the 2nd power. All right. Now, again, you could recall we know there's going to be alternating signs. First term's always positive, and then a negative, and then a positive. So, again, good news is our term's going to be positive. Same thing here. That exponent's an even number, so we're good to go. We got a little bit of calculator work here to go. 4C2. You may have just memorized that, or you throw it in your calculator. That's a 6. We got a little work here to do. Now, I'd start with the coefficient. If I square that coefficient, I get 25. But then you look at the exponent, and we're not going to square the exponent. Power raised to a power, we're going to multiply these two rascals right there. We're multiplying them, we're going to get x to the 10th. So make sure we know how to handle the difference between a coefficient versus the exponent. And then that last component, let's see, if I square the -3, I get +9, and then multiply those exponents and get a 4. And just one little more move here to make. 6 times 25 times a 9, calculator says 1350. Then we'll just bring down our variables here. And that, ladies and gentlemen, is what the middle term would look like if we expanded out that entire binomial and got all 5 terms. But so today was a little easier. We didn't have to get all the terms. We just had to focus and put all our energy into one term, work on cleaning it up without any careless mistakes, and we're good to go. So I hope you enjoyed the shorter version tonight. Good luck tomorrow, and finish strong on your Big Friday.